Alright, I have nailed down the architecture of Linen for now. This is subject to change, but hopefully this will be pretty good and solid. The plugin itself is a Flax Linen plugin, like we described before, and this will manage the its own plugin lifecycle and all the subsystems, be it an RPG system or other. So essentially this is our core plugin, is the linenflax.h and .cpp. So basically our linenflax is our main plugin class that manages all the different game systems. And some of this is untested, and we'll get to that stuff in due time, but I've got quite a bit nailed down that I think we can just continue on implementing various systems and get them working together. So far, I have before we get into which systems we have, I'll talk about the base system architecture first. So we have our plugin that manages our systems. These systems are hierarchical in that they are classes and extended classes. So our Linen system is our most simple base class system. It has some serialization stuff, so if you were to say make something other than an RPG system, you could extend this class and implement it similar to RPG system and extend that other system. So like maybe it's a racing system, and so that way you could have different types of systems that could be managed by Linen itself. So this is the base class of everything, all the systems. And RPG system is an extension of that base class, and it's a pretty simple thing. Realistically, you could probably combine this with the Linen system. I didn't do that because I thought it would be beneficial to separate out different systems from one another. So you had like RPG specific systems, race specific, like racing specific systems, that kind of idea. It's probably not needed to split apart the RPG and the Linen system itself, but because there's nothing really RPG about this, but I don't know, I thought maybe it would architecturally make sense for the future if we decide to add other systems, other system types than just RPGs. So every system extends this RPG system class, so we'll get rid of these two. Let's look into the character progression system, and this is all the systems kind of build off of the same architecture. So one kind of mirror, like one system, like quest system and the time system, kind of mirror this character progression system. So we have a skill class, and this skill class does its own stuff that will be used by the character progression system. The character progression system has a bunch of stuff like getting its instance. Here, we'll move this together so we can kind of talk about this together. Here, I'll move this to, well, that's fine. So I'm using a Meyer singleton, which basically has a static instance, a static pointer instance of some system, which is itself, and it's going to return that. So when you call getInstance, it will return a pointer, a static pointer to whatever system you're trying to get the instance of. So in doing so, we kind of need to manage the lifetime of that instance, that static instance. So what we'll do in a destroy method is we get that static pointer instance, and we delete that instance and then set it to null. So that's kind of the lifetime of this. It should always exist in the same memory location, so anything can just talk to it without too much trouble. And then we have our RPG system interfaces. We have our Lennon system stuff, and then we have our skill stuff, our skill and character progression system. So we have like a level down here and our experience, and we have event handler that will handle a quest completed. And then, so yeah, I won't really go too much into the C++ stuff of this, but essentially we have our skill, character progression system. All this stuff should theoretically be self-explanatory. The implementation details of, handling the character progression, so like experience levels and our skills. So that shouldn't be too much trouble for you. So like I said before, our quest system will mirror kind of that same character progression system hierarchy. So we have a quest class, and this is everything to do with the quest. We have the quest system itself, which is essentially, mirroring that same structure of the character progression system. So we have our create instance and destroy instance. And yeah, so basically all this does is manage a quest, a map of quests. We have a string and what quest it is, and its implementation details are also pretty self-explanatory. If I go to the top here, we have our quest stuff and our quest system specific stuff. So you can add a quest, you can activate it, you can complete it, you can fail it, and then there's different stuff about getting a quest, getting all available quests, getting all active quests, getting all completed and all failed quests, and then obviously our serialization stuff for saving and loading. Our time system is very much similar to the quest stuff. Actually, in the quest, back to the quest stuffs real quick, we have events. These so quest completed event, quest state changed event. So when something happens with the quest you're on, we can be notified of certain stuff. And I guess I'll go into quest types, kind of explain this slightly. So in quest system CPP, we have we'll use fail quest for an example. We have this quest state. This is just kind of a more verbose version of Boolean, like failing and loading, or failing, like true and false values essentially. So we can say that if a quest is active, if it's failed, if the quest state itself. So let's go back to types. So we have these 4 quest states. Is it available? Can you accept the quest? Is it active? Are you actively have the quest selected? And if that quest is completed or failed. We have our quest result. This is actually the management of the, like what I was trying to say before with the quest result. This is like our more verbose Boolean version. So is the quest not found? Is it an invalid state? Have we successfully found the quest to fail? And if not, everything returns as error. So you can kind of see how the quest system works with that. get out of that, go back to the time system. So here we have our time related events. So has the day changed? Has the hour changed? Has the season changed? We have enum class for what time of day it is. And the time system mirrors the other stuff. I guess I can explain this. We don't really want to have an assignment operator or a copy constructor because we're using the Myers singleton, so there's only ever going to be one of these. So that's why we don't want to copy it and we don't want to assign it to anything. It should statically exist in our memory, and everything should talk to that one static instance. Yeah, it's pretty much. This one is probably the most advanced system so far. As advanced as in, there's a lot of functions to it. If we go in there, this is one of the more longer systems. We have like 600 lines. A lot of it is basic math to calculate time day stuff. I am actively working on this one. We can actually see this in game. So if I start this, oh right, it's compiling. So we can see the time of day changing. We can speed this up, let's say like 10. So you can see the moon tracking. Actually, let's speed it up a little bit more. We'll go 25. We'll go 60. So, should come around, should become day. There's the sun. Sun tracks. Real-time shadows. Comes down. Moon comes up. Tracks. And you could change which way that kind of figure eight pattern. So it goes up high noon. So the time system is actively interacting with the game world. Go back into here. So that this time system is actually being talked to through this day-night cycle script. And we have a bunch of API fields, some private member variables, and our basic script stuff. And then updating the sun's rotation. So if we go into there, this is pretty self-explanatory. Like I said, I was working on this actively, but it should work for now until I figure out why I have to force time advances. I have an idea why, but I won't get into it. But yeah, we have some math that calculates everything to properly put the sun and moon in the right locations. Yeah, so that's the time system. Let's talk about serialization a little bit. So serialization is honestly probably one of the more complex parts of this, because we are doing both binary and text. So we have our writers, we have our readers, and essentially we are writing data and reading data, and we have text writers and text readers and binary writers and binary readers. So this is probably one of the more complex parts so far. Since the character progression, the quests, the time, all that stuff is pretty rudimentary, whereas this is, dealing with files and stuff and data. So this does work. If I scroll down here, save, this is the text. The test save.bin is binary stuff, so you can kind of see what's going on here. We have some basic, it's basically the same thing as test save.txt, but in binary. I won't go too much detail about the serialization, but just know that it's there. So our save load system is a system, just like character progression, quest, time, that sort of stuff. So all the different things should implement their serialization and deserialization stuff. So if I go back to quest system, we see we have those. So if we go into there, let's click down here. So we have serialize, it's doing the binary writing. Deserialize, that's doing the binary reading. Serialize to text, that's doing the text writing. Deserialize from text, that's doing the text reading. So theoretically, you should be able to save and load anything. So if we go into the quest system or character progression system, we have the same stuff, but it's context specific. So get out of that. So yeah, this is excuse me, mirroring the same stuff as before. Mirroring the same systems as we were before. We'll actually go into this. So in the, where is it? Here we go, save game. So here we go. This is kind of like, saving and loading the stuff, if it's going to be binary or text. And then it goes through a bunch of different stuff. Here you can see we are actively saving each system out specifically, and then actively loading each specific system. Yeah, this is pretty self-explanatory. It's using all those serialization stuff. So serialization.h. This save and load system uses all this. Using all this stuff. And each system will use the serialization as well. So we have these helpers, if you will. So like writing a vector, writing a map, that kind of stuff. Writing different value types. And the same is true for the reading and text reading and writing. So like write vector text, write map text, that kind of stuff. Save to file, that kind of stuff. Let's get out of this. Let's talk about the event system. So the event system is what handles the communication between stuff. So we are essentially, excuse me, I'm so exhausted apparently. Looking through my notes here, sorry. Trying to find something. Oh, I guess I could talk about this. Oops. So we have file streams, and let's see if I can find them. I'll just do it this way. I guess I don't really need to talk about that. Just basic saving and loading. Oops, I spelled it wrong. Yeah, I don't really need to talk about the strings, or the streams, but essentially we're doing resource acquisition as initialization. I was looking for the event stuff. Okay, so in my notes, so the type system uses type erasure to handle different type of event types. This one is pretty cool because I love the observer pattern, where you can, like some system can subscribe to events and publish events. This allows that decoupling of systems. So, for example, that time system has these events that could be subscribed to, and so you would be listening for these events. So maybe quest system would be looking for a specific season or a specific day or hour, and it would listen for these events to then do something itself. So that's kind of how you can have interoperation between each system, right? So this event system is handling all that, and we are using filtering capabilities, and we have priority. So when you subscribe, you can filter, and when you publish, you can have a priority and you can filter. If you want to publish immediately, you can through some filter, if you would like. And so basically some system would subscribe to an event, another system would publish or publish immediately, and then the event system would process events, and it's through a queue. So we have some queue of events, and we don't want to miss any events. So there's a queue, and it's a priority queue, and we are queuing up these queued events, and we have some comparison, so that way we can detect the priority later on. So basically, the higher the priority means you get a higher priority in the queue. So maybe some event matters more than another event, and you could set it that way, and and that way you could have events like, for example, maybe the RPG that you're building is much more time sensitive, or quest completing and failing. Maybe you want that at a higher priority or something like that, but maybe like the day changes, or the other type of time changing, or season, maybe those are higher priority because they get called less or something like that. Like however you wanted to hook it up. So let's go to this other file. We have this linen test. Okay, so this is also a script. So a Flax script. So this is just like the day-night cycle in that it's a script, meaning you can go to some object and attach a script to it. So for example, this measurement tool I have here, it's got the linen test script and the day-night cycle script. So this thing is managing the directional light. So that directional light is getting its modifications. You could attach it to the sun if you wanted. You could, the very flexible component system there. Now, this linen test is pretty cool because if we go into it, when this linen test script gets ran, we're going to get the plugin, and this is the Flax stuff. So we're getting the linen Flax plugin. When we have that plugin and it matches some stuff that we decided, if the plugin exists and the type ID equals this linen Flax plugin, then we can do some stuff on it, because now we know that this linen Flax plugin is available to us, so we can we can access the systems within the linen Flax plugin. So we have we're testing the character progression system right here, adding a skills, increasing those skills, what their skill levels are, experience stuff, and then we're just outputting stuff to the log. So if I scroll up here, I have to scroll up quite a bit because there was a lot of time. So here we go. So we loaded that plugin, the initialize ran, the different systems were initialized and registered. So these systems were registered for serialization. Different systems so basically, if I go back in here, if I get some system, remember that the oh yeah, here, we didn't talk about this. So we have this template implementation of a get system. So this is going to get a specific RPG system by type. So here we're doing some type checking and returning that specific get instance that we talked about, that Meyerton singleton, and we're returning that type that instance, right? So we can get that instance and we can do stuff with it. This should be available anywhere. So we have, I'll scroll down through the quest stuff, the time of day, the time day stuff, time day season, all that sort of stuff. We have some serialization stuff for the time itself. So I have a different save file for time of day. It actually includes everything here. So I was just testing out different save files for different things. Maybe I'll expand more on that later, but for now it's just it's gonna save everything, because like we showed before that we were doing all the different systems within these. Maybe we could have like save system, load system, that sort of stuff. This is what I wanted to get to though. So these events. So right now I've been messing with the time, day, night cycle stuff. In here, where is it at? Okay, so yeah, right now, for example, I am getting the plugin with this day-night cycle, and this is on update, so this is kind of bad, but it's just for testing until we can flesh this out a little bit further. We're getting the plugin. If that plugin that exists, then we'll get the system of the time system. If the time system does exist, then we can do things on it, right? And so this should be replaced with the event system. We shouldn't be getting the plugin and getting the system here on update. We should be looking and listening for some event that happens. That's really what this needs to change to. But for, I had showed you before that it works, and so we'll just leave it as is for now. But know that the time, the night cycle, day-night cycle stuff, that will change in the future. Where was I at? Oh yeah, linen test. So these events get published. So what we're doing is the plugin is subscribing to these events, and if these events happen, then these will get printed. That's how this works right here. And save and load stuff, and then the test system. This was the first system that I implemented, which if I go to the top of here, oh wait, no, it's not in linen test, it's in linen flax. So I have this baseline test system, testing things out, so it follows the Meyer. This is how I figured out how to do the Meyer stuff, essentially, and the saving and loading, serialization, that kind of stuff, before I implemented it in the other systems. That's kind of where that goes. Yeah, so that's what I have so far. I can't wait to get into more of the design aspects of, actually creating these scripts that are going to listen for events. That's really where this tutorial is going to kick off. Right now we're just kind of waiting for me to get everything set up, and now that we have a solid character progression system, a quest system, save and loading, and the time, as these are kind of I wouldn't say static. We'll look into doing things further in the future with them, but now that they kind of work, we will, like I said, we'll get in more into that, listening for events, publishing events, that kind of thing. More we'll shift more into the event stuff. But essentially, I'll just kind of recap. We have our core plugin, which is Linen Flax. Let's look at the code so we can see what we're talking about. So this is the core plugin. This is the core game plugin that when we get it, then we can get the subsystems. Our base system architecture was the Linen system, the RPG system, and the event system. That's the base system architecture. Where's the event system? Let me open that up. If I can read. Oh my gosh. So yeah, these are our three base architecture classes. And then we have our game systems, character progression, quest system, save and load, time system, and then all the different supporting files that go along with that. So like quest events, quest types, serialization, that kind of stuff. We have our linen test. That's going to be our test script that tests everything. So this should always exist and test all the different each part of the system fully. And yeah, outside of that kind of stuff, let's open up. I guess we could just keep it in here. So I just wanted to go over real quick about the different patterns we used. We used the singleton pattern. We are implementing the Myers singleton pattern. So that get instance and destroy stuff, that's like the thread safe static initialization of our different systems so that they can be accessed, the same system can be accessed everywhere globally. Our observer pattern, which is the event system stuff, so you can subscribe and publish events, that kind of stuff. The factory plugin pattern, so our linen Flax plugin is creating and managing the system instances. So in the initialization, we are setting up that plugin reference. We are initializing those different instances, and then we're updating them, processing events. So it's kind of how that works with the factory. The strategy pattern, we have the different serialization stuff, binary versus text. This serialization format is encapsulating the different types and the binary readers and writers and the text readers and writers. Those are encapsulating the different serialization formats. So we have our strategy pattern there. Dependency injection. So when for example, this system, we have a reference to actually it's an RPG system. We have our linen Flax plugin pointer. So this set plugin reference is so that we can access the other systems from within a plugin. And so that's doing dependency injection, this set plugin. When a system is storing a reference to the plugin is injected via this method. Our template method pattern, so basically we have a base system classes that define these interfaces, and derived classes are implementing them. So so like the serialization, initialize, shutdown, that should be in the event system. So all that stuff. So the RPG system class is not implementing them, it's just setting up more layers there, and then each system should implement all those different things. So we're overriding there, overriding here, that kind of stuff. And then what else do we have? Systems can have dependencies on other systems, so it's in this one. I'm using forward declarations to reduce the header dependencies of each system. Most of our if it's some set or get, that implementation is kind of in the header, but more complex details are within the C++ file itself. So, for example, the serialization and deserialization, we're not going to put that in the header. That's kind of what we're doing there. We went over the type erasure to handle different type events and how the... Oh, did I go over the... I wonder if I went over the event handler. So, this event handler base is acting as a base class for the different types of event handlers, for type-specific handlers. So our event system, you see we're using our template functions, so we don't have to go drill down all these different types that would possibly be used here. So we're erasing the type from the event system so that we don't have to manage all the different system types. Builder pattern used in serialization.h. So yeah, we're just essentially constructing serialized data and deconstructing deserialized data, or well, rather deconstructing serialized data. Yeah, we're doing templates. There's a lot of templates in the event system stuff. Yeah. So essentially, so far the plugin should be well structured with a clear separation of concerns, and it leverages relatively modern C++ effectively. Here I'll do this. So in our build, we're using C++ 17. Yeah. Just trying to read through all my notes and see if I missed anything here. Yeah, so I'm trying to emphasize the modular extensible systems with clean interfaces between the different components of it all. And yeah, so far so good. We got a majority of the baseline set up. So this was a large undertaking itself. Sorry it's taken so long, but I wanted to get everything so that it worked fairly well. Well enough to continue on, and then in the next video we will really go into more of the RPG system stuff itself. So more about the design. This is kind of like the boilerplate, if you will, of everything. Okay, well, I'll see you next video.